Thanks for coming. Welcome to Consensus 2024, and really appreciate you coming by the Flow Hacker House today. My name is Santos. Friends call me G. Most folks around here know me as G. I'm the engineering manager and tech lead on the developer experience team at the Flow Foundation. Previously was a senior engineer on the mobile team on the Dapper side of things. And I've been there for over 3 years now, so it's an exciting place to work with, an incredible team and community. You can hit me up for questions after. I'll be around for sure, but otherwise you can always find me on X as well at Santos. All right, so today I'm extremely excited to talk about and perhaps introduce to many of you EVM on Flow. I think it might be good and interesting to start out with some of the motivations and goals, and then I'll give a high-level technical overview of the implementation, and then I'll follow that with a lightning-fast demo to illustrate how easy it is for you to begin developing on Flow EVM today. We'll deploy and interact with the standard ERC20 contract on Flow with zero code changes, and we're going to use Foundry, one of the most popular Ethereum development frameworks. So a little history here. Flow was built from the ground up for mainstream scale decentralized applications. We introduced a novel multi-node architecture that Ali mentioned, as well as resource-oriented programming language called Cadence, and that's designed specifically for smart contracts. While Cadence provides powerful security and DX benefits for developers, its biggest hurdle, arguably, to wider adoption has been the inability to take advantage of the apps and tooling that already exists in the Ethereum blockchain until now. Flow EVM introduces full EVM equivalence on Flow, giving developers complete flexibility to deploy any Ethereum DApp with zero code changes. Secondly, perhaps more importantly, it enables EVM apps and contracts the ability to take advantage of the incredible features native to Flow. Consumer scale features like account linking, account abstraction, secure enclave, key cycling, and batch transactions. I'm pretty sure that once you learn more about our design and implementation and see our seamless developer experience, you'll agree that though there's myriad EVM chains and layer 2s abounding, they're not like us. So, as I said, I want to start by sharing some of our initial motivations for adding EVM support and 3 key things we saw as essentially non-negotiable requirements. Our main goal was to connect Cadence to Ethereum and provide features and a path crucial to scaling EVM apps to be consumer ready. Now, we talked to many people over the years, and this was a big hurdle to adoption. There's considerable investment in code and infrastructure and resource constraints that didn't allow them to rewrite contracts, even if they were interested in the features that we had to offer. So number 1 of those non-negotiables, equivalence. We believe compatibility is insufficient. So the difference between compatibility and equivalence, compatibility is the ability to interpret EVM bytecode, while equivalence gives the ability for EVM code, tools, and infrastructure to work with minimal to no code changes. Now, many apps and providers support EVM. They have a substantial investment in infrastructure and existing code. So we need to ensure that existing smart contracts and code need to work in the same way on our platform, without any concerns around APIs, opcodes, gas, security models, or side effects. Client-side tools like wallets and indexers must function without changes, and cross-chain bridges and code libraries should be able to depend on the same set of assumptions that hold true on Ethereum. We aim to remove any risk associated with adding a new platform, and as a developer or infrastructure provider, you can adopt this platform without having to rethink your code or your security model. Number 2 is composability with Cadence. That's our baby. EVM must play nice with applications that are already deployed on Flow and the developers who are working there. And our implementation, we believe, allows for Cadence smart contracts to securely extend functionality and offer full composability between Cadence and EVM. This is facilitated by the introduction of Cadence-owned accounts, which I'll touch on in a bit, and a protocol-level atomic asset transfer. And third, unlocking those Flow features that I talked about. We needed to ensure that the incredible features and scalability benefits native to Flow were made available to the entire Ethereum ecosystem. So, Flip 223. After initial forum posts from Deet late last year and some breakthrough ideas from Rampton on our team, we proposed Flip 223. Thanks to all our amazing engineers on the foundation and community feedback, which was incredible, it shaped up to a solution where confident requirements were met, all 3 of those requirements. Minimize changes to tooling and code. So trusted protocols like Uniswap, OpenSea, MetaMask, Chainlink, Layer 0, Aave, Curve, the gamut. And tools that developers use like Remix, Hardhat, and Foundry, which I'm going to give you a little demo of, they work right out of the box. While current and new Flow devs can write Cadence smart contracts to extend and build with composability with EVM assets and code, both can take full advantage of Flow's mainstream focused features for onboarding and UX and the unique capabilities of Cadence. High level of composability across VMs was also very important to us. So that composability allows for support for atomic cross-environment calls, and EVM code can trigger functionality in Cadence and interact with Cadence assets like fungible tokens and NFTs once bridged. And most importantly, and most obviously, no sacrifice to safety and security of either environment. So some of the pieces here, the core design and key decisions. Number one, Flow is the native token. So that removed a lot of complexity around adding a new token to the ecosystem, and it also increases the utility of Flow for holders today. Number two, Cadence as a point of entry. This is a powerful thing that allows Flow transaction format to be reused, and Cadence has full control over the outcome of EVM transaction execution. That also is what provides for the atomic operations across those environments. And another key decision is really the main design here, and that's EVM is essentially emulated inside of Cadence. We do that with a single new EVM smart contract deployed on Cadence, and that's what allows the ability for both sides to interact. And then lastly, quite an innovation and something net new here is Cadence-owned accounts, or COAs, as you might see them. These are a net new, brand new EVM smart contract account type. It isn't controlled by an external key like an EOA or a smart contract itself. It is controlled by a Cadence account. So the keys and the ability to move and transfer assets is all controlled by your Cadence account. Too long, didn't read here, is whenever you create a new COA, you receive a Cadence resource which provides control over an address, an EVM address. On the EVM side, an address is allocated and smart contract is deployed which supports common ERC standards. So over that, the last few years talking with folks who were having some challenges to move into Flow, we identified three key personas who spoke to us the most now and can benefit from equivalence. The first one is cross-chain infrastructure providers. That's folks like the OpenSeas, Oracles, Bridges, centralized exchanges, cross-chain decentralized exchanges. And their world-class tooling and APIs built for EVM can now simply run on Flow, just by deploying on Flow. They can deploy unchained Solidity contracts that have already been audited, perhaps, and definitely vetted the same way they would to any other EVM-based chain. And so that's the bottom line, is we want them to be able to build simply, and they can build simply, as if Flow was any other EVM chain. Second group are Ethereum app developers. User-facing apps, consumer apps, and the developers who create them, they can benefit from this almost as simply as infrastructure, because there's no code changes or changes to their tool sets. Step one, they just need to point to the Flow JSON RPC gateway. That's a familiar thing for any other chain. And then step two, as we say, profit. They can develop these apps using the same familiar tools and frameworks like Remix, Hardhat, and Foundry that they're used to, and users can use the same wallets like MetaMask, Rainbow, etc. And along with that, the contracts, they can leverage battle-tested code, community-vetted code from things like OpenZeppelin. And the third, this is just a little taste of what can happen so you can deploy your EVM contracts and code as is with no changes. However, if you want to take advantage of those features, you can extend them with Cadence. Accessing Flow features that I already mentioned are account model, transaction batching, on-chain randomness. They can extend those Solidity contracts just by wrapping them, in essence, in Cadence contracts. And that allows features like being able to equip NFTs with accessories, attaching unique data, which Ali touched on with attachments, things like autographs, stickers, and some of the other examples that Ali gave, or remixing your NFTs to compose something brand new. and integration with Cadence assets. So any existing Cadence NFTs and fungibles and resources on the Cadence side can be interacted with on the EVM side once bridged at that protocol level. The third group is the Cadence developers. We love you, and we didn't forget you, and you're primary for us. So they can take advantage of all the EVM side that is coming. So that means they can import, first of all, they can import the EVM smart contract, which is that emulator piece, and it's essentially on after that. They can interact with Solidity code from Cadence side. Any assets are accessible via the bridge. And also, as soon as we start to bring in these folks on the EVM side, the Cadence developers and apps have access to EVM infrastructure and services that are going to be growing on that side. As I mentioned, control of EVM assets via the Cadence owned account. And things like MetaMask support now have potential for Cadence DApps. So a little bit more complex here to actually implement, but not so much. Probably pretty familiar in the Ethereum world. You can take advantage of user signing and approvals for off-chain messages and delegate that control to a Cadence smart contract. And then a COA, as part of that Cadence smart contract, can now handle the verification logic and submission to the chain. Now, all of this is coming, Flow EVM is coming as part of the Crescendo upgrade, which I'm sure you heard about this weekend from Sean and others. And it's actually available today on PreviewNet. So we're going to do a little demo, and you can immediately start kicking the tires on this today. Testnet, scheduled for late June 2024, not too far away now, and mainnet end of summer 2024. Let's do a demo. So we're gonna deploy a simple ERC20 contract using an OpenZeppelin library. Another thing I mentioned with Foundry, most popular tool. How many folks have used Foundry in this room? Anybody? Just like 10 of them back there. Okay. It's a very popular tool these days. Probably the primary tool for Ethereum development, and it's pretty simple and great. So now, in the interest of time, I did a couple things up front, very minimal. I just installed Foundry. I created a Foundry project with the forge init command, and then I installed that OpenZeppelin library just to speed things up and not put too much strain on the Wi-Fi. The last bit, I set a variable for the RPC URL, and that's the PreviewNet URL right there. So that's the JSON RPC that we're talking about, and any of these tools, you just point to that and deploy. All this stuff I'll have in the last slide with some references for you to follow up with. All right, so we have my code editor on the left here, and this is the guide that I'm mostly freestyling, but we're going to follow, and you can find that in the references as well, so you can follow along after. And as I mentioned, I've got my RPC URL set to the PreviewNet. And what I'm going to do is create a wallet with the cast tool. And we receive key pair and address. Now I'm going to set these locally for convenience. It's going to be our address here. Set the private key as well. Okay. And then I'm going to fund this account via the Flow faucet. So if I can see what I'm doing here. Because you start off the account with 0 flow, so we just need to add some for development purposes. I could send it from MetaMask or anywhere else, but we're going to use the faucet to fund here on PreviewNet. It's also available for testnet. All right, we got 1,000 flow. So let's check this balance here. That's the deployer address, that's correct, and our RPC URL. I just put the Ether flag there so it'll break it down based on GUI. And we have 1,000 flow. All right, we're good to go. So what's next now? The boilerplate code from Foundry gives you a default contract, counter, and a test. And I also, in the interest of time, which I didn't mention, added this simple ERC20 contract that imports the OpenZeppelin library, and it declares a token contract here that implements the ERC20 standard, and then we have access to everything from that. That just has one mint function right here, which takes an initial mint amount. And I created a test for it as well. So why don't I just run tests just to compile and confirm. All right, test pass. So now we're ready to deploy. So now we're going to use our, give me 1 second here. Oops, we're back. Okay. Just give me 1 second to find my command. It's a different tool.
Everyone's waiting for bated breath.
Yeah. So we're going to call forge command here. To create this, we're going to pass our deployer private key, that constructor we mentioned for 42 million, and pointing it at our contract address. So here we go. Compile that contract. All right, so we've got deployed to address, that's our contract address. And if I can do a little more gymnastics here, we should jump into, we have a temporary block explorer right now. So we can immediately take a look at a transaction. If I refresh that a few seconds ago, that looks like it. There's our transaction. And we can see my token deployed right here. Fantastic. All right, so running back into the guide here, just to jump down. We created our wallet, we checked our balance, we compiled and tested, we deployed that contract, and now we're going to interact or query this deployed contract. So we use the cast tool again, and we're going to check the balance first off of that minted. So we check the balance, deployer address, and our token address. Oh, I got an error there. Oh, I didn't set my variable, so I'll just do that real quick. Grab the deployed to address. And we want to go with the deployed my token for simplicity. And we're calling the balance with our endpoint, deployed token, and the deployer address. And 42 million was the mint amount. So now we can also call specific functions on that contract. We're going to go cast. We want to look for the balance of, there it is. We should get the same amount, 42 million. And then lastly, we can check the token symbol. Probably faster if I just typed consensus coin. There we go. Okay, now let's interact. We can do a couple more things here before we're done. So we're going to send transactions, and we're going to send some of these consensus coin to another address. So first thing I'm going to do is create one new wallet using the cast tool. And now I've got a new address and private key locally here. And I can just grab that address. Don't need to fund it because we're going to send it some tokens. And I will export that as my new address. Bingo. And now we should be ready here to send some tokens. We just want to make sure we have the new address. So we're deployed token address, the RPC URL private key, and we're transferring to the new address, 42 tokens. Give that a second to run. Successful. We got a transaction hash in our logs. If we look at our Explorer, a few seconds ago, that should be it. And can't quite see, but I believe it's there. But let's just check the balance here, and we can ensure that it was sent. So that's the RPC URL, my token address, and my new address. 42 tokens. We're good. And if we check the balance of our deployer, we should see 42 less. Boom. One last thing, as Steve Jobs says, but there's one more thing here. I'm going to see if I can. So, I have, yeah, here we go. I imported my MetaMask address in here as a variable, and I'm going to send some tokens to my MetaMask. So I got my deployer private key, the correct RPC URL, and then if we jump over here to MetaMask, I got 4049 currently. Boom, 4091. So that's on PreviewNet today. And you'll have access to play around. I'll be around for questions for the rest of for today and tomorrow. So, and feel free to hit me up on X if you need, Greg Santos. Scan that QR code and you'll have access to all the references, the guides, and everything else we talked about today. So thank you very much. Yeah.
Before you stop, so because that last part, you glance over there, you're like, oh, let me just send some flow to my MetaMask.
Yeah.
So in layman's terms, you funded your wallet with Flow originally.
From the faucet, yep.
From the faucet, then launched an ERC20 token.
Yep, with that as the deployer, that account as the deployer.
Is that SCOA?
No, this is just a straight EVM here. We're not even touching the Cadence side.
Interesting.
When do you? For some of those bits I mentioned about extending. So now if I launch this contract and I want to extend it with some of those features that are only available on Cadence, can wrap that contract and take advantage of the Cadence side using COA, Flow wallets.
So you could add capabilities or things like that on top of that ERC20 token?
Yeah, exactly. Essentially, wrapping is the easiest way to describe it, but this is all deployed on Flow EVM. It's all Solidity code. All the tools are the same. The only change, essentially, as you saw, is the endpoint. But at this point now, it's deployed on EVM side. You can take advantage of the protocol bridge, move it to the Cadence side. You can wrap that in a Cadence contract and extend at will. Any other questions? Yeah, I'm happy to take them if you have them now. Otherwise, I'll be hanging around. Yeah.
So I remember there was some adapters or extenders. What was the word for it? You guys are using for
Attachments.
attachments. Yeah. So there's a couple of attachments that could extend your code on the EVM side. Is that integrated at the get RPC level?
No, so that's an example of extending. So your Solidity code is a contract that runs as is. If you want to take advantage of the Flow features, that's when you would use the protocol bridge, wrap it in a Cadence contract, and then you have access to all the features on Flow, including attachments.
Interesting. Okay, and the Cadence contract wrapper, is that, like, what does that do?
I'm using the word wrapper because I think it's just the most simple, but there's no like protocol level wrapper. It just essentially means you can use those tokens and any assets from the EVM side within Cadence contracts themselves. And since it's part of Cadence now and it's in a Cadence contract, then you have access to all the features.
Okay. Sweet, thank you.
Yeah, sure. Any others? All right. Thank you very much. Talk to you soon.